So, hi, Professor Bell. Thank you so much for joining us today at the World of Aerospace. My name is Vince Sandoval, and I'm a high school junior from Texas, and I have a strong interest in aerospace engineering and planetary science. So, I'm currently involved in a rocketry team, and we run World of Aerospace, where we share insights with other students in this community. Now, I'm really excited to speak with you because of your work on the Mars missions, and it's very fascinating. But before we dive into the Q&A questions, would you mind starting by introducing yourself and sharing a bit about your background and what you currently do?
Sure. So great to meet you, Vince, and thanks for doing the interview. I'm Jim Bell. I'm a professor here at Arizona State University. I'm talking to you from our campus in Tempe, Arizona. I am a planetary scientist, which means I'm a part geologist and part astronomer. Started out in the telescope world when I was a graduate student and have been involved in space missions, robotic space missions for NASA and other agencies for 30 something years. I mostly work with cameras and spectrometers. I'm trying to figure out the geology and composition of planetary surfaces using remote sensing, basically from robotic spacecraft. For example, we run the cameras, the zoom cameras on NASA's Perseverance rover here on campus. I have a staff and a bunch of students that do that for NASA every day. If you saw movies of the Ingenuity helicopter fly on Mars, I don't know if you saw any of those movies, but that was my team downstairs in this building that I'm in. Took those movies. So we do a lot of work for NASA and write a lot of research papers and work with students who get their master's and PhD degrees with this data sets. So thank
Okay.
you again. Yeah.
Yeah, so let's go back a little bit. What inspired like your passion for planetary science and exploration, particularly concerning Mars?
Oh my gosh. Well, in general, so when I was a little kid, there were guys driving cars around on the moon on TV,
Mm,
which was just amazing, right? It's
yeah.
like incredible. I want to do that, right? I still haven't been able to do that. Maybe someday.
Yeah.
But that was super exciting. And then I got a telescope. I lived in a dark sky place and got to know the sky and planets and comets and stuff like that, the moon.
Yeah.
And then when I was around your age, there was a show on television, and this was, back in the day when there were only three networks on TV and PBS. That was it. And so there wasn't any science hardly at all on TV, but there was a show on PBS called Cosmos by an
Mm,
astronomer named Carl Sagan. And it was revolutionary for the time because it was science television narrated by and hosted by a scientist who was an outstanding scientist, but he could also speak plain English. He could like talk regular talk. I mean, my mother loved Carl Sagan, right? And so just learning about the solar system and the galaxy and beyond every week on that TV show with the latest from the landers on Mars or the Voyagers going out to the outer solar system was truly inspirational. And then probably like you and many of your friends, a lot of great teachers, a lot of great mentors, support from family members, all that stuff. And then suddenly I was able to make a career out of it. Amazing.
yeah. Okay. But was there any like specific mission that really solidified your interest in Mars, or is it just your childhood moments?
Well, I was interested in Mars going back to the Viking missions, which were the
Mhm.
first landers on Mars, 1976. I was 11 years old, and I remember watching on TV as the pictures came down real slow, one line at a time. It was like watching paint drip down a wall, but it was super exciting still. And that was exciting. And then just kind of the luck of the timing of when I was born and when I went to college and when I went to graduate school. While I was in graduate school, it happened to be during a time when Earth and Mars were making a bunch of very close approaches, and the professors I was working with were doing some new observations with some new instrumentation on telescopes, and so I was just in the right place at the right time, which often happens.
Yeah, okay. So that's great. So let's go into like let's start talking about some more Mars exploration and imaging stuff. So you were the principal investigator for the Mastcam-Z imaging system on NASA's Perseverance rover. So I'd like to learn more a little bit about it, but what are the primary objectives of this instrument and like how does it enhance our understanding of the Mars surface?
Yeah, so the main goal of the Perseverance rover is to be the first part of Mars sample return, a robotic set of missions that will bring back samples from Mars, very well selected samples. And so I have a prop. There are 42 of these tubes inside the rover, and inside each tube is a sample of a rock core that was
Hmm,
cored out, not just drilled, but cored out and
okay.
pulled out of the rocks. And it's about the size of a piece of chalk. If you might not know what a piece of chalk is, but maybe people older than you would know what a piece of chalk is.
Yeah.
And so we have collected 30 of these on Perseverance so far, and we have about 10 more to go. And the idea is to a future mission will bring them back. So our goal is to collect those samples and study this ancient lake bed environment where there's a beautiful delta, like at the end of the Mississippi River, that flows into the crater. And on Earth, this would have been a very habitable environment when the water was flowing and the sediments were being gently deposited. We don't know if it was a habitable environment on Mars at the time. We don't know if it was inhabited on Mars at the time. We need to bring these samples back.
Yeah.
We've got great samples from a place that was a lot more like the Earth a long time ago. Mars isn't like the Earth today, right? It's much colder, much drier. No obvious signs of life on the surface of Mars. We don't know what's going on deep underground. But in the ancient past, early in the history of the solar system, same time the Earth was young, Mars was a lot more like the Earth. And so we use the cameras to help figure out where to collect these samples. We do all the geologic mapping, taking landscape images, helping at high resolution and or wide angle or both, helping other geologists on the team figure out where's the best place to take these samples. We work with the orbiters above Mars and those pictures looking down. We work with engineers who drive the rover. There are licensed rover drivers on the team who know how to drive these things, and it's all done in basically in virtual reality. We're not joysticking them in real time. It's too far away,
Yeah.
right? So we send a bunch of commands and they do a lot of autonomous work in the driving to get from point A to point B. But the cameras help them do that. And then they're color cameras, but we also have filters that let us see a little bit in the ultraviolet and a little bit in the infrared with these cameras. And so we can use those to say something about the kinds of minerals that are there as well. And again, help us find the best samples for eventually a future mission to bring back.
Okay, so like you've seen a lot of things, but what's been like the most surprising or striking like thing that you've captured so far?
God, where do I begin? Yeah, I don't even know. But maybe, the interesting thing is when you've seen a bunch of these pictures from Mars from a bunch of missions now, right? There have been missions going back to the 90s that have landed and sent rovers to Mars. And it's interesting how it looks familiar.
Mm,
You might say to yourself, like, I live in the desert Southwest. You might say, oh, it looks like, my neighbor's backyard. No vegetation, lots of reddish rocks. I could go on a hike there. But the reality is, that environment would kill you in so many ways, right?
yeah.
There's no oxygen to breathe. The pressure is super low. The temperature is crazy low. There's ultraviolet and radiation coming down from the sun, unfiltered to the surface. I mean, yeah, when people go to Mars, and I'm an optimist, I believe people will go to Mars. It will be the harshest environment that humans have ever gone to.
What year do you think we'll be able to actually get to Mars?
Uh, I mean, I don't know. It's always seemingly been a few decades away. I don't think we could do it right now technologically.
Yeah.
There's lots of problems that have to be solved for life support and and also just the cruise, making sure people are safe on the cruise and how to try to be sustainable in some way, live off the land as much as possible, try to maybe use the atmosphere to generate some rocket fuel for the return trip, because of course we want people to come back too, right?
Yeah.
We don't want them on a one-way trip. So, I think there's some technology and engineering that needs to be developed. Maybe more importantly, there needs to be a will, a national will. When in the 60s, it was national will that allowed us to beat the Russians to the moon. It was the president deciding this is important for the nation. It's going to drive technological development. It's going to drive innovation. It's going to drive inspiration. It's going to drive global leadership for the U.S. And it did all those things, right? But it took at the time 4% of the government's budget. That was the NASA budget was 4% of the U.S. budget
Wow.
for the Apollo program. Today, the NASA budget is 0.4%,
Wow.
10 times less. So
Crazy.
it's to with will has to come the funding to do that, and funding means you need congressional support, administration support, public support, right? And so I think that yes, while we have many technological and engineering problems to solve, and we'll learn amazing things and all that, what we learn and build will trickle down to make life on Earth a better place. It really requires kind of a ramping up of interest among everybody who wants to see something like that happen. So probably we could get, if we decided tomorrow this is in the national interest, we're going to do this, we're going to spend a little more higher fraction of our precious tax dollars to do this, we could probably have people on Mars in 10 or 15 years. Certainly the Chinese have announced they want to have people on Mars by the early 30s. And so they're heading out in that direction.
Okay. Well, we've also had like a lot of technological advances though in the past, since the space race. But how have like those advancements in imaging technology over the years improved our ability to study Mars, and what challenges remain in capturing high quality images from the Martian surface?
Yeah. I think a lot of people don't realize how much of the technology that goes into NASA work shows up in our everyday lives. I mean, the camera in your cell phone, that technology was developed for NASA space missions decades ago, right? The GPS, the GPS in your cell phone, right? That's the space program working for you.
Mhm.
And so a lot of the advances that we're seeing in, I don't know if you guys have driverless cars in your community yet, but Phoenix is one of the test markets for driverless cars in the country, and it's weird seeing a car without a driver and people in the back seat. But a lot of the technology that's gone into that has come from a lot of the robotics that NASA has done with driverless rovers on Mars, right? Similar kinds of software technology, much better computing power available here on the Earth because we don't have to launch that stuff out into space. But there's just a lot of technologies, especially innovations, inventions, patents that have come out of just pure exploration. And it's often hard to know what is going to become of the innovation or the invention or whatever. I mean, back in the day when a bunch of physicists were messing around with materials, they invented something called the transistor, and it's like, what is that used for? Who knows? I don't think maybe it's not going to be used for anything, and it's completely changed the world, right? So it's just really hard to know, but there are a lot of tangible things that are possible to know where the space program has really benefited our civilization, our society, and people's lives.
Okay, so what do you think is like the most necessary like imaging upgrade that we need next for future missions to help like really improve?
I'll give you a surprise answer. Maybe you weren't expecting this answer. It's not the imaging, it's the bandwidth,
Mm.
right? We've got, I mean, I've got I don't know what this is, 10 megapixel sensor in
Mhm.
my
Yeah.
phone, right? You can go buy 50, 60 megapixel sensors at your consumer electronics store down the street, right? And that's great, but that's a lot of pixels, and there's no internet to Mars or to the asteroids or to Jupiter or Neptune. There's no internet, right? So you can't get those pixels back to the Earth.
Mhm.
So really what's needed most for imaging geeks like me is bandwidth. I want more downlink. I want, better. I want interplanetary 5G, I want that kind of technology. And there are ideas about doing that. And certainly when people go back to the moon in just a few years, there will be orbiters and communication infrastructure that's much better than what was there in the 60s. And there's probably be streaming live video direct from the moon that'll be much, much better quality than the TV broadcasts that came in the 60s.
Okay. What significant geological or atmospheric discoveries have been made on Mars, and like how have they influenced our perception of Mars, like as a potentially habitable place?
I could spend about 3 hours giving you that answer,
Yes.
but I won't. Probably the most significant discovery of the past few decades is that there are places on Mars that we've sent rovers and landers to, that we discovered from orbital data, that were, by Earth standards, were habitable
Mm.
early in the planet's history. That is, there was liquid water, there were heat sources, organic molecules raining down from asteroids and comets, just like on the Earth over time. So the ingredients for life, as we know it, the environments for life, as we know it, a thicker atmosphere, warmer surface temperatures. There were places on Mars that were like that 3 billion years ago, 4 billion years ago. Mars is the same age as the Earth. The whole solar system is 4.5 billion years old, approximately. And, we know that on the Earth, life formed very early, almost as soon as it could, as the planet was cooling and it went from a molten, volcanic, steamy world to the rocky planet that we know and love today with oceans on it. And it's almost as soon as possible, life emerged on our planet. Did that happen on Mars? We don't know. Wouldn't it be nice to know? Wouldn't it be good to know if life can pop up everywhere that it can, then it's all over the galaxy and the universe, right?
Yeah.
And if it didn't, why didn't it? And what does that mean about life on Earth? Are we alone? I mean, these are profound questions, and there's a place right next door, metaphorically right next
Yeah.
door, on the scale of our solar system, where we can go test those hypotheses and try to answer those big questions. So
Yeah.
just the revelation that Mars was a lot more like the Earth, always a little colder because it's farther from the sun, but a lot more like the Earth a long time ago than it is today, and therefore may have been another haven for life as we know it. I think that's probably the most profound discovery of all these Mars programs over the past few decades.
Okay. So, what specific minerals on Mars have been like most helpful in tracing like its geologic past?
Well, first of all, the periodic table is the same on Mars as it is on the Earth,
That's
as
right.
it is on Neptune, as it is on the Andromeda galaxy, right? It's the same elements. And in fact, we find a lot of the same minerals on
Mm.
Mars.
Yeah.
On Earth, a lot of what comes out of the volcanoes on the Earth, we find the same things on Mars. A lot of the kinds of clay and water-bearing minerals that we see in lake and river environments on the Earth, we see them on Mars. And so in general, it's probably those clays and water-bearing kinds of minerals that preserve the evidence of past water on the planet and help us map that out across the planet. That's probably the most interesting and revealing set of minerals that we found there.
Okay. How does Mastcam-Z help identify those materials, those minerals?
Well, it's not a spectrometer. You really need a spectrometer to do that,
Yeah.
spread the light into
Okay.
hundreds, thousands. But we do have filters that sample some of it, so we can detect certain kinds of minerals, especially iron-bearing minerals, iron oxides, the things that make our soils reddish on the Earth, also make the soils on Mars and the rocks reddish as well. Same kinds of minerals, so we can detect some of those. We have some ability to detect some of these clays I was talking about, but very limited. It's really the other spectrometer instruments on the rover that do that much better because they're optimized for it. But we provide the geologic context. We can take big picture landscape views and high resolution as well, and really understand the details. Whereas the spectrometers, they go in like a needle, just pointing at a certain couple of spots. They can't paint the whole landscape with spectroscopy.
Okay. Um, so you mentioned that like in order to uh like, because you mentioned that in the past we had about 4% of the budget was going into NASA, right? And now it's almost like 0.5%. So if we were to increase that to 4% or even higher, how important are the collaborations between like the scientists, the engineers, and the mission planners of NASA? Like how important are those interdisciplinary collaborations to contribute to the success of planetary exploration endeavors for the future?
Well, those collaborations are critical regardless of the size of the budget.
That's
Okay,
right.
absolutely essential. I mean, nobody's expecting NASA's budget to grow by 10
Yeah.
and anytime soon, right? You know what's going on in the world today, what's going on in the country. The
Yeah.
government is shrinking, not
Unfortunately.
expanding, right? So nobody's expecting that. So we have a responsibility to be good stewards of whatever we're granted by the taxpayers and Congress.
Hmm.
And part of that responsibility involves being a team, and scientists and engineers, and by the way, managers and administrators and lawyers and you know janitors, everybody who's
Everybody.
involved in NASA projects and facilities and research. We all have to work together as part of a team to use those precious resources absolutely wisely.
Yeah. Okay. But what role does public engagement and education like play in advancing space exploration? And
Yeah,
how do you approach communicating complex scientific concepts to like a broad audience?
yeah. I mean, public engagement is absolutely critical. It's the public that is funding this,
Right.
right? It's your taxpayer. I don't know if you pay taxes, but maybe your parents or grandparents or whoever in your family pays taxes, I would imagine.
Mhm.
But it's an investment that the American people are making, and the American people make investments all over the government. Lots of the science that and exploration and laboratory work and all the medical research, all that kind of stuff is investments that we're making. And so it's critical to be able to demonstrate and communicate back to the public, here's the return on your investment. These innovations, these inventions that are now trickling down into consumer electronics or your everyday life, or these textbooks that are rewritten by U.S. funded programs, rovers or orbiters or flybys or astronauts or whatever, or maybe it's just inspiration and leadership, and the that great feeling that we have that we are leading the world in doing this kind of exploration. These are all returns on investment, and it's absolutely critical that we communicate. And where did I got my cue from Carl Sagan, where we started, right back when I was a kid. It's so important to communicate, so important to be able to try to get the word out on why this kind of stuff is important for the country.
Okay.
It's why it's important for your community, why it's important for individuals, and so I take it really seriously. I spend a bunch of time talking with school groups and church groups and museums and others, and I write popular science books, and I try to pay it back because the public has paid it forward.
Yeah. So would you say that communication is the most effective way to get people excited about Mars, or is it something different?
Communication is absolutely critical. We have to be able to demystify it. It shouldn't be some jargony, esoteric, sciency thing, right? It's got to be like, how does this affect me? Where's my return on my hard-earned taxpayer investment?
Mhm.
So it's absolutely critical. Hey, we're running out of time.
Okay. Do you have to go by 3:30?
I do.
Okay. Maybe I'll just ask you one more question, but so what guidance would you offer to students and aspiring aerospace engineers who are interested in pursuing careers in planetary science and space exploration?
Well, first of all, it's obviously important to be a curious person, to be interested in science, engineering, technology, math, coding, building things, taking things apart. These are all what scientists and engineers do, but mostly it's being curious about the world around you, finding problems and getting excited about solving problems. And perhaps the most important thing is whatever you decide to pursue as a career, make sure you're passionate about it. It can be anything, literally anything. As long as you're passionate about it, you're going to love it, and it's going to be incredibly rewarding when you do it. And when you love your job and it's rewarding to you, you're going to make discoveries and innovations and inspirations, and people around you are going to love working with you and all that kind of stuff. Just have that passion for whatever it is that you
Yeah,
want to
so
pursue.
yeah, that was like very inspiring talk that we just had. But so like for the viewers out there, is there like how can they reach you if they have any questions? How could they reach you?
Well, I mean, I work at Arizona State University. You can, I'd hesitate to say email me because I get hundreds and hundreds of emails a day, and I'm not very good at responding. So, but you were persistent, so that was good.
Okay.
But yeah, I mean, I can certainly try to respond to email.
All right. Well, thank you for your time. So,
All right.
yeah.